Good morning, students. So today we will learn one of the very common techniques of finding out the square root of numbers. Now, this is a topic which is mostly taken up at the 8th standard, or the equivalent levels, 8th standard in your mathematics. Okay, so what is it that is special in this particular lecture is that we will be understanding, we'll be getting to learn an easy way out of memorizing something which is usually forgotten after it is learned in the 8th standard. Okay, so it's not the memorization of any answer or any lines as such, but it will be purely the memorization of the way of finding out the square root. Okay, so as you can see here, finding out the square root of numbers by long division method. Okay, so let us first understand why this method is required before actually learning this process itself. Okay, so we will understand the reason why we need this particular method, which is known as the long division method. So let's talk about some squares of the natural numbers. So square of 1 we all know is 1. Square of 2 we all know that it is 4, so 2 into 2 is 4. Similarly, we have the square of 3, which is 9, and square of 4, which is 16, and so on and so forth. Okay, so this is something that you really do not need to memorize, because it is already embedded. By the time you reach 8th standard, you are pretty familiar with all these things. Okay, the problem arises when somebody asks you, or you get a question in which you have something like this. Let's say, for example, you have something like this. Now, we are talking about squares just now. With the help of squares, we will take a backward process, or let's say a step backwards, or look in the other way to find out the square roots. So just like we had, let's say for example, 2 square. So we knew the answer is 4. Similarly, when we will try to find out the square root of 4, this number, so it is like going from this side, left side, to right side. We are doing the squares. Okay, so 2 square is 4 when we go from left to right. Similarly, when we want to come back finding out the square root of 4, it should give us 2. So we know that naturally, when you put this sign, it naturally means square root. Sometimes you also have this number 2 written over here. Okay, so what do? You take out the prime factors of 4, so you have 2 into 2. Okay, and since it's a square root, so you will club 2 of the numbers at a time. Okay, so out of this particular bracket, only 1 2 comes out. So this is how you get an answer 2. So square of 2 gives you 4, and the reverse process, which is the square root of 4, should give you 2. So it is giving you 2. Now this is an easier method to follow, because the number itself which we are finding the square root of is small. Okay, the small numbers, if you want to try to find out the square root of smaller numbers, this is the better way, or this is the most easy way, this is the easier way to memorize and to learn. Okay, but again, as I said, the problem will come when we have bigger numbers. Okay, so let's say for example, we have the square of 42. So let's talk about the square of 42. So let me just multiply 42 by 42. 2 2s are 4, 2 4s are 8, 4 2s are 8, and 4 4s are 16. So you have 4 here, 8 and 8 16, carry 1, 6 and 1 7, and this. So we have 1764 as the square of 42. Okay, now if somebody asks you what will be the, so I'm going the backwards way or the reverse way. So let's say for example, if somebody wants to find out the square root of 1764. Okay, if somebody wants to find out the square root of this number, Now when you have this written in front of you, you naturally know that 42 is the square root of 1764. But what if this comes without you knowing that 42 square is 1764? So finding out the square root of 1764, if you take up that prime factorization method, then it will become lengthy. Okay, so that is why we need to, and mind you, this is only 4 digits. You can have 6 digits, 8 digits, 9 digits, and finding out the square root of such large numbers. Okay, so in that case, although prime factorization method will still work, but it will be lengthier. Okay, so you need to develop a method. The method is already developed, we need to only know how to use it. So that method is long division method. Okay, so we will pick up a few examples, 3 examples, each of different kinds. Okay, so first number that we will take is, let's say for example, somebody wants to find out the square root of this number. Okay, so even if you don't write this small 2 over here, it will be understood with this sign that it is finding out the square root. Okay, so what is the first step that you will follow? The first step that you will follow is make pairs. Okay, make pairs from the unit side. Okay, so we will be making pairs from the unit side or from the right side. Okay, so what is our number? Our number is 3844. So let us see. We have 3844. Let me write this particular number like this. So that is the method that I am going to tell you about. Okay, now the first step says that we have to make pairs. Pair means two numbers at a time. So we will use bars from the right hand side. This is the unit side. Unit, tens, thousand, hundreds, thousand. Okay, so unit, 10, 100, 1000. This is the way you go. So from the right hand side, you start making pairs. So these two numbers make a pair. So you put a small bar at the top. Similarly, the next two remaining numbers will form the next pair. Okay, so the first process is now over. Now you will look for the second step. Second step will be to find the number whose square is either 38 or lesser. Okay, so I am going to take up this particular example and use this example in the steps that I am telling you. So find the number whose square is either 38. Why 38? Because I have my first pair here as 38. Okay, so I have to choose a number over here whose square gives me 38. So 38 is not a perfect square, we all know that. 36 is the nearest lesser square number. So we get 36 only when we do 6 into 6. So it is the square of 6 which gives me 36. Okay, so please understand that we have to put the number here as well as that same number here. So that 6 into 6 when you multiply. So these two numbers will get multiplied. And remember, these two numbers have to be same. It is here that students generally make mistake. They use 6 sevens or 5 6. We cannot use that, because essentially what we are doing is we are finding out the square roots. And remember, finding out the square root is the opposite process of the squaring of numbers. So when you square numbers, you multiply the number with itself and not with a different number. That is why these two numbers have to be same. So they may be 7 7, they may be 8 8, they may be 9 9, but they have to be same. Okay, depending upon what pair you have here. So 6 6 are 36. Had we done 7 7s, it would have become 49, which would have exceeded. So my number has to be either lesser or equal to that pair. So now what we do is, normally the way we normally do, we subtract these two numbers. Okay, so on subtraction what we get is simply 2. Okay, now what do? You bring this 6 over here just below that number and you add these two numbers. Okay, so let me write down the third step. The third step will be to add the number to itself. Okay, so this 6 number has been brought down here. So here there will be multiplication going on, and in this line it will be the addition going on. Okay, so 6 plus 6 gives me a 12. Okay, now in the normal division, had this been a normal division question, only the next digit, singular digit 4 would have come down. But since this is a square root finding, so we will bring the whole pair down. So the next pair, which is the last pair, will be 44. Okay, so the number becomes 244 now. Now, the last step would be the fourth step. So you find a number here. So let me put a block over here and let me put a block over here. So why, the reason why I'm putting a block in these places is because we have to look for a number. Remember, look for a number which when multiplied with this same number will give you this digit over here. Okay, so remember, you can have 1 into 1, so 2 into 2, 3 into 3, but then the easier way out will be to look at the last digit here. Last digit here is 4. So how do you get 4? Do you do 1 into 1 and you get 4? Do you do 3 into 3 and you get 4? No. There are only two ways in which you can get 4 in the end. So you either do 2 into 2, which will give you 4, or you do 8 into 8, which will give you 64, and 64 will have 4 number 4 in it. Okay, so here what we will do is we will use a little common sense. We will use 2 because this number, actually you can see that if you use 2 over here, that same number 2 has to come here. Remember, again, if you use 6, same number 6 comes here. If you use 2, same number 2 comes here. The only difference here is that this time it is not just this 2 which will get multiplied with only this 2, but this 2 will get multiplied with the whole number present here. Okay, so 2 into 2 is going to give me 4, 2 into this 2 is going to give me 4, and 2 into this 1 is going to give me 2. So you can see that it is exactly the same number that has come. Had we used 8 and 8 here, although we would have got 4 here, but then the overall number would have exceeded. Okay, so 2 into 2. So essentially this boils down to this. Okay, so what that means is, now again remember, let me write this fourth number. Choose a number whose square gives the number on the right side or lesser. Okay, so these steps are not so important. This is only for understanding the flow. If you have understood how it is being worked over here, these steps should not matter much. So in the last process, again, as we had after multiplication, we had brought down this 6 here and added. Similarly, this 2 will be brought down here and again added. Okay, so 2 and 2 will give you 4, this 2 and this 1. Okay, so that completes my process of finding out the square root of this number. So what is the answer? The answer is 62. Okay, so when you will do 62 into 62, you will see that you will have 3844 as the square. Okay, so this is one way. Now in the next question I will use up an example of a decimal number, because you can always have questions involving finding out the square roots of large digits which have large numbers which have decimals also involved. Okay, so let me see. Okay, so my next example is finding out the square root of 72.25. Now it is natural for everyone to know that you cannot really get this using the prime factorization method directly, okay? And nobody remembers what is the square root of 72.25, okay? So we have to work here. We have to have a few steps to follow before we get the answer to this question, okay? So let us see how we can go about this. We will use that same process of long division. So we will have let's say 72.25, and we will draw a line here and we will draw a line here. Now the first step, again remember, was from the unit side. So this is the unit place, let's say, for example. So from the right side we will have pairing being done, okay? So this is the first pair, this is the other pair, okay? And certainly you have a decimal over here which will change things just slightly, okay? So the first step, again, your first pair is 72. So you look for a number which when multiplied by itself will give you either 72 exact or lesser than that. It should not exceed 72, okay? So 9 nines will become 81. So therefore 8 8s would be a better option. So 8 8s 64, okay? Then when you subtract, you get 8 here, okay? And remember, once you have multiplied, you need to bring this 8 down here and add. So you have 8 and 8 adding up to 16, okay? Now had this decimal not been here, I would have brought this 25, these two digits down here. But since there is a decimal over here, so what I will do is I will put that same decimal here at the top, okay, in the quotient, okay? So let's say, for example, after putting this decimal, what am I left with? I'm left with this 25. So let me bring this 25 down. Remember, we have to bring the whole pair down, okay? Now again the process will be to make a block over here so that I can put same numbers here which when multiplied will give me this 5, okay? So how do you get 5 in a square? What is that number which you can square to get 5? Answer is only 5. 5 5s are 25. If you do 1 square, it gives you 1, 2 square 4, 3 square 9, 4 square 16, so 6 in the end, 9 square 81, 1 in the end, 8 square 64. So essentially this last digit actually gives you a small kind of a shortcut as to what number should be put over here. So let me use that number 5 here. Remember that same number 5 will come here also. So 5 5s are 25, carry 2, okay? 5 6 are 30 and 2 32, carry 3. 5 1s are 5 and 3 is going to give me 8, okay? So you can see that after subtraction there is nothing left. And remember the last process again, this digit 5 has to be brought down here and added. Now this will not matter much because there are no further digits involved, but then just to complete the solution, so 5 and 5 after addition will give you 10, carry 1, 6 and 1 7, so you get this as the answer. So what is your square root of 72.25? It is 8.5. so that is your answer, okay? So this is the way you will use, and naturally you can have more digits here, you can have 2 more digits here, and so on and so forth, okay? So that is the idea. Now coming to our last question of this lecture, which will involve more than 4 digits, okay? So till now, if you notice, we used a decimal question, we used a question with 4 digits. Now we'll move on to a question involving 5 digits, because you see till now the pairing has been exact, okay? So you will till now you have been having numbers where the number of digits have always been even, okay? So we had 72.25. so if you remove the decimal, the number of digits are 4, okay? Similarly, in the first example also the number of digits were 4, so you were getting exact pairing was being done exactly. Now in this question, let us say, for example, I will take 1 0 2 0 1 as an example, Okay, so this is a rather strange looking number, but we will see that. Let me just write this down more clearly so that you can have a little space for working also, and it is easily visible also. So this time we have to find the square root of this number. Naturally it is not going to be easy using the prime factorization method. It's a long number, it's a pretty large number, and the other significant thing here is that if you count from the right hand side, start making pairs, this will be the first pair, this will be the second pair, and there won't be any other pair left. You can see that there is only one digit left. Okay, so you will leave that digit as it is, or you can imagine that there is a 0 over here. Okay, so this is the only thing that we have. If you want, you can put a 0 here, although that would not make much difference. Okay, because if you put a number, if you put a 0 before any number, it will not change its value. Okay, so this is essentially the way you will solve it. So once again, the first number over here has to be 1, because 1 into 1 is going to give you 1. Okay, so after subtraction it gets cancelled out. Next step is bringing this 1 down, so you have 1 plus 1 coming out to be 2. Next pair will be brought down, so that next pair is this. Okay, now you have to be very careful here, children. When you have brought this pair down, this pair itself has digits 0 and 2. 0 is coming before 2. So if you look at the value of this pair, it is only 2. Okay, the 0 is not having much significance here when we talk about these two digits. So the value of this pair here is 2. Okay, that is the idea. Now the process is, again, select a number here, so that when it gets multiplied with the same number here, you get this number here. Okay, so if you notice carefully, I cannot put, let's say for example, let us do trial and error method. I put 1 and 1 here because there is no number whose square comes out to be 2 in the end, okay, as the last digit. So if I put 1 and 1 here, 1 into 1 so will give me 1, but when you do 1 into 2, it will give me another 2. So I am going into a number 21, which is far more than 2. Okay, remember the method said that you have to use such numbers here which after getting multiplied should be either equal to this number or lesser than this number. But this number itself is so small, it's 2, that you cannot even have one number here. 1 into 1 gives you 1, and remember you have to multiply this 1 with this 2 also. So 1 into 2 will give you, so basically 21 into 1 is going to give you 21, which is becoming more than this. Okay, so that is the reason why you must have, this is the reason why this question becomes important, is because you have to select a number here lesser than 0. So lesser than 0 is only lesser than 1 is only 0. So you have 0 into 0 giving you a 0, okay, and 0 into 2 will also give you a 0. This is the only possible option, or this is the only possible number which when multiplied with itself will give you either 2 or less than 2. The moment you go beyond 0, I showed you 1 here, 1 and 1, so that is going to give you 1 into 1 1 and 1 into 2 2, so that will become greater than 2. Okay, so 0 into 0 is going to give you 0, and 0 into 2 is also 0. Again, let me take off this 2 from here. So when you subtract again, you get that same number. 2 minus 0 is 2. Okay, remember you have to bring this 0 down here and add. Okay, so once you add it up, you are going to get 20 again, because 20 plus 0 is 20 essentially. Okay, now remember the last step, the last pair is still left. It has 0 1. I will bring this 0 1 down, and you will see the difference now. When I bring this 0 1 down here, because there was already a 2 existing here, So now this number has become 201, whereas here when I brought down this 0 2 pair, this 0 did not have any value because there was no number before that. Okay, but here before the 0 there is a 2, so this becomes 201. Okay, so now again you have to select a number here, so that when you multiply that number with the same number here, you get 201. So naturally common sense should tell you that it has to be 1 and 1, because 1 into 1 is going to give you 1, 1 into 0 is going to give you 0, and 1 into 2 is going to give you a 2. In short, it is 201 into 1, so that gives you 201 exact, which after cancellation, after subtraction, will give you nothing. So there is nothing, no remainder left, and naturally the last step, bring this one down here to complete the step, add it up, so you have 202 left here. Okay, so this is the process that you have to follow. Please go through the lecture carefully. I have taken up 3 different examples. At the 8th, 9th and 10th standard, you will not face any problems beyond this particular level. Okay, so the 3 questions, decimal question, odd number digit questions, and even number digit questions of finding the square roots have been discussed. I hope you have understood it. So the answer to the square root of 10,201 will be 101. Okay, 101. So when you square 101, you will see that you get 10201. Okay, so I hope that this lecture will help you, because I have seen students who have reached 9th and 10th standard, and they do not fully remember the process, the way, the steps, how this long division method of finding out the square root works. Okay, although this is taught at the 8th standard level, 8th level, but then because of the lack of usage of these questions, or whatever could be the reason, students generally do not remember the way how this is done. Okay, so I hope this acts as a revision.